If you Google search the keywords 17 equations that changed the world, most likely you will get this list of the 17 equations that changed the world. How many of these equations have you heard about? And how many of the equations that you have heard about you understand their concepts? Well, if you study additional mathematics, you should know logarithm and derivatives. You might also have heard about Euler's formula. Do you notice that there is one equation that looks very simple but powerful, and it is ranked number 1? Yes, the equation is Pythagoras Theorem, which is the topic that we want to learn in this lecture. This is GCE O Level Mathematics, Lecture 26, Pythagoras Theorem. Hello everyone, Dennis here. The learning objectives of this lecture are: first, state Pythagoras Theorem, followed by apply Pythagoras Theorem to solve problems involving right-angle triangles, and lastly, apply converse of Pythagoras Theorem to determine whether a triangle has a right angle. As I mentioned at the beginning of the lecture, Pythagoras Theorem top number 1 in the 17 equations that changed the world. We can see Pythagoras Theorem almost everywhere around us. It is used extensively in building construction. As you can see in this picture, 3 workers are working on steady scaffolding, which is made out of a lot of right-angle triangles. Similarly, this picture also shows that the structures are made out of many right-angle triangles, which make it very stable and can hold great pressure and weight. As you can observe, right-angle triangle is a basic structure but powerful. The question is, how do the workers make sure that the angles are right angle, which is 90 degrees, as they construct tall buildings? We will discuss about it at the end of the lecture, so do stay tuned. You may wonder who is Pythagoras. You can search information about him from Wikipedia, and this is his statue. This is the summary about Pythagoras. As you can see from here, he was born in 570 BC and died in 495 BC, when he was around 75 years old. He was not only famous in mathematics, he also gave great contributions in ethics, music, politics, and religion. Not only Pythagoras' theorem, he attributed many other ideas, such as 5 climatic zones, 5 regular solids, proportions, and so on. You can search his name in Wikipedia and find all the information here. Here is an interesting story about how Pythagoras came up with his theorem. One night, Pythagoras could not sleep. He lay on his bed and opened his eyes wide. He saw a lizard on the ceiling crawling from one point to another point. Then one question came up in his mind. How far has the lizard traveled? He believed they should have an accurate way to calculate the distance that the lizard had traveled. He noticed that the ceiling had black lines which made up a number of squares. After much thought, he finally came out with a method. He thought of a right angle triangle. The two shorter sides of the right angle triangle is labeled as A and B, and the longest side of the triangle is labeled as C and name it as hypotenuse. According to Pythagoras, in a right angle triangle, the square of hypotenuse is equal to the sum of the squares of the other two sides. And the relationship between A, B, and C can be described in this equation: C squared equals A squared plus B squared. And this is the formula of the Pythagoras theorem. So using this formula, now he can calculate accurately how far has the lizard traveled from one point to another point. Right now, let's see how we can use Pythagoras theorem formula to solve some questions. Example 1. Given this diagram. In triangle ABC, angle ACB equals 90 degrees, AC equals 4 cm and BC equals 3 cm. Find the length of AB. So here's the solution. We know that Pythagoras theorem is C squared equals A squared plus B squared. So the C here is AB, which is the hypotenuse, and we know the values of A and B are 4 and 3. Hence, AB squared equals 4 squared plus 3 squared, which gives us 25. Therefore, AB is square root of 25, and the value is 5 centimeters. Then we can say the length of AB is 5 cm. Now, you can try this similar example yourself. Given this triangle, in triangle PQR, angle PQR equals 90 degrees, PQ equals 5 cm, and QR equals 12 cm. Find the length of PR. You can pause the video and try to solve this yourself. Alright, so here's the solution. First, start with the Pythagoras theorem formula. C squared equals A squared plus B squared. So the hypotenuse C is PR. Hence, equation becomes PR squared equals 5 squared plus 12 squared, which is 169. Hence, PR is square root of 169, which is 13 centimeters. So we can say that the length of PR is 13 centimeters. Now, let's see example 2. Given this triangle, in triangle XYZ, angle XYZ equals 90 degrees, XY equals 24 cm, and XZ equals 25 cm. Find the length of YZ. So here's the solution. First, start with the Pythagoras theorem formula. C squared equals A squared plus B squared. So for this case, you want to find YZ, so which is one of the sides of this triangle, and the hypotenuse is 25. Hence, equation becomes 25 squared equals YZ squared plus 24 squared. Hence, YZ squared equals 25 squared minus 24 squared, which is 49. So YZ will be square root of 49, which is 7. Hence, the length of YZ is 7 centimeters. Okay, so you can try this yourself. Given this diagram, triangle STU has a right angle at angle STU with SU equals 17 cm and ST equals 8 cm. Find the length of UT. You can pause the video and try to do it yourself. Okay, here's the solution. Start with the Pythagoras theorem formula. C squared equals A squared plus B squared. We want to find UT, and hypotenuse is 17. So equation is 17 squared equals UT squared plus 8 squared. Hence, UT squared equals 17 squared minus 8 squared, which is 225. So UT will be square root of 225, which is 15. Hence, the length of UT is 15 centimeters. Now, let's see one more example how to use Pythagoras Theorem. Example 3. In the diagram, angle ACB equals 90 degrees, AD equals 10 centimeters, BD equals 9 centimeters, and DC equals 6 centimeters. Find the length of AC and AB. So here's the solution. From triangle ACD, by applying Pythagoras Theorem, C squared equals A squared plus B squared, we will get 10 squared equals AC squared plus 6 squared. So AC squared equals 10 squared minus 6 squared, which is 64. So AC equals square root of 64, which is 8. Hence, the length of AC is 8 centimeters. Next, we want to find the length of AB. So we need to look at triangle ABC. From triangle ABC, by applying Pythagoras Theorem, C squared equals A squared plus B squared. The hypotenuse is AB. So the equation becomes AB squared equals 9 plus 6 squared, which is the length of BC, and plus 8 squared. So we'll get AB squared equals 15 squared plus 64, which is 289. Hence AB will be square root of 289, which is 17. Hence the length of AB is 17 centimeters. Now let's try this example yourself. In the diagram, so here's the diagram. Angle PQS equals 90 degrees, PR equals 50 centimeters, QR equals 14 centimeters, and RS equals 76 centimeters. The question is, find the length of PQ and PS. You can pause the video and try to do it yourself. Alright, so here's the solution. To find the length of PQ, we need to look at triangle PQR. So from triangle PQR, by applying the Pythagoras Theorem, C squared equals A squared plus B squared, where the hypotenuse is 50. So the equation becomes 50 squared equals PQ squared plus 14 squared. Hence PQ squared is 50 squared minus 14 squared, which is 2304. Hence PQ is square root of 2304, which is 48. Therefore, the length of PQ is 48 centimeters. Next, to find the length of PS, we need to look at triangle PQS. Hence, from triangle PQS, by applying the Pythagoras Theorem, C squared equals A squared plus B squared, where the hypotenuse is PS, and the length of SQ is 76 plus 14. So the equation becomes PS squared equals 76 plus 14 square plus 48 square, which is 90 square plus 2304, and the value is 10,404. So PS is square root of 10,404, which is 102. Therefore, the length of PS is 102 centimeters. After learning how to use Pythagoras Theorem, now let's learn how to apply Pythagoras Theorem in words problem. So let's look at example 4. Given this diagram, in the diagram, a top wire AB connects point A on a vertical wall to point B on the horizontal ground. Point A is 2.4 meters above the ground and point B is 1.8 meters from the wall. Find the length of the wire. So here's the solution. By applying the Pythagoras Theorem, we can see that the triangle ABC is a right angle triangle. Hence, the equation becomes AB squared equals AC squared plus BC squared, where AB is the hypotenuse. So AB squared will be 2.4 squared plus 1.8 squared, which is 9. Hence, AB equals square root of 9, which is 3. Therefore, the length of AB is 3.0 meters. Try it yourself. Number 4. given this diagram. The diagram shows a rectangular swimming pool which is 20 meters wide and 50 meters long. A swimmer swims from point R to point P in a straight line. Find, correct to three significant figures, the total distance that the swimmer has swum. You can pause the video and try to do it yourself. Okay, here is the solution. From this diagram, as you can see, PRQ is a right angle triangle because this is a rectangular swimming pool, so this will be 90 degrees. So we can use this triangle to apply the Pythagoras theorem. PR square equals PQ square plus QR square. So we substitute the values. PR square equals 20 square plus 50 square, which is 2,900. So PR equals square of 2,900, and the value will be 53.9, rounded up to three significant figures. Hence, the total distance that the swimmer has swum is 53.9 meters. Now, let's look at example 5. Given this diagram, a tent is set up as shown in the following diagram. It is supported by a post RT with the height of 2 meters. RS and RU are two strings connecting the tip of the post R to the horizontal ground. Given that RS equals 5 meters and RU equals 4 meters, find the base length of the tank SU. So here's the solution. From this diagram, we can see that it is made out of two right angle triangles. The first one is the triangle RST and the second triangle is RTU. So we want to find the length of SU. So first we need to look at the first triangle RST. So from this triangle, we can apply the Pythagoras theorem where the RS is the hypotenuse. So equation becomes RS square equals RT square plus ST square. So we know this value is 5, this RT is 2. So substituting the equation, 5 square equals 2 square plus ST square. So we can find the ST square, which is 5 square minus 2 square, and ST is square root of 21. Next, we look at the second right angle triangle, which is RTU. So we can apply Pythagoras theorem where RU is the hypotenuse. So it will be RU square equals RT square plus TU square. Then we know RU is 4 meters, RT is 2 meters. So substitute the value inside here. So we have 4 square equals 2 square plus TU square. Hence, TU square equals 4 square minus 2 square, which is TU equals square root of 12. Therefore, now we want to find the base length SU, which is ST plus TU. It becomes square root of 31 plus square root of 12. We press calculator and we get the value is 8.05 meters, rounded up to three significant figures. Therefore, the base length of the tank SU is 8.05 meters. Try it yourself. 5. Given this diagram, in the diagram AD is a vertical building with the height of 50 meters. Benny stands at point B and Charles stands at point C. Both of them are at the same horizontal level. Given that AB equals 120 meters and AC equals 80 meters. Find the distance between Benny and Charles, correct to three significant figures. You can pause the video and try to do it yourself. Alright, so here's the solution. For this question, we need to find the length of BC. So to find the length of BC, we need to see that this diagram, there are two right angle triangles. The first right angle triangle is triangle ACD, and the second right angle triangle is triangle ABD. So we find the length of CD and the length of BD. Then to know the length of BC, just take BD minus CD. Okay, so first we will look at the right angle triangle ACD, where the AC is the hypotenuse. So to form the Pythagoras theorem, we have AC squared equals AD squared plus CD squared. Then we substitute the values, we'll get 80 squared equals 50 squared plus CD squared, where CD squared equals 80 squared minus 50 squared, which is square root of 3, CD is square root of 3,900. Now we move on to the second triangle, triangle ABD. So the hypotenuse is AB. Now the equation becomes AB squared equals AD squared plus BD squared. Then you substitute the values. AB is 120, AD is 50. Then BD squared will be equals 120 squared minus 50 squared, where the value of BD will be square root of 11,900. Hence, the length of BC will be square root of 11,900 minus square root of 33,900. Hence, the length of BC equals 46.6 meters. Rounded up to 3 sigma figures, then we will say that the distance between Benny and Charles is 46.6 meters. Let's discuss one more example on Pythagoras theorem application. Example 6. Given this diagram, the diagram shows the cross-sectional view of a train tunnel where PQ equals RS, which is 8 meters. QR equals 15 meters and the height is 5 meters. Find the width PS of the bottom of the tunnel. So here's the solution. From this diagram, we can see that PQRS is a trapezium. And these are the parameters given. So this is also 5 meters. Let's label this as point T, and this is point U. From triangle PQU, as we can see, it is a right angle triangle. We can apply Pythagoras theorem, where PQ square equals PU square plus QU square, and apply the values given. 8 square equals PU square plus 5 square. So PU square equals 64 minus 25. Hence, PU is square root of 39, and TS is also square root of 39. So the length of PS will be PU plus UT plus TS. Then substitute all the values inside. We'll get the length of PS is 27.5 meters, rounded up to 3SF. Hence, the width of PS is 27.5 meters. Let's see, try it yourself 6. Given this diagram, the diagram shows two vertical buildings which are 36 meters apart. Given that AD equals 40 meters and BC equals 55 meters. A piece of cable is connected between point A and point B of the two buildings. What is the length of the cable? You can pause the video and try to do it yourself. Okay, so here's the solution. From this diagram, we can draw a right angle triangle and we can label this as point P. So from this triangle ABP, we want to apply the Pythagoras theorem because we want to find the length of AB. But we have a problem. We don't know what's the length of BP. So BP is this length. To get this length, it will be BC minus AD. So it will be 55 minus 40, which is 15 meters. Now we can apply Pythagoras theorem, which is AB squared, which is the hypotenuse, equals AP squared plus BP squared. Then we substitute the values 36 squared plus 15 squared. So AB squared will be 1521. AB is square root of 1521, which is 39. Hence, the length of the cable is 39 meters. The last topic of this lecture will be converse of Pythagoras theorem. Now let's experiment it. Get a piece of rope that is longer than 120 centimeters. Using a marker pen, mark 13 points at intervals of 10 centimeters along the rope so that you will get 12 sections of equal lengths. Tie the rope together at the first and the last mark to make a loop of 12 units. Then try to form a ragged triangle with this rope. What will you get? You'll get something like this, where this is 3 units, this is 4 units, and this is 5 units. This is the same method where ancient Egyptians used to form right angle and build majestic buildings that stood strong for over 5,000 years and still standing. They tied knots that were of equal distance apart along a rope to form 12 sections of equal lengths. Then they stretched out the 12 sections to form a special triangle with whole number of sections on each side. 3, 4, 5. So these 3 numbers are called Pythagoras triplet. Pythagoras triplet combinations commonly used are 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. And their multiples. So for example, 3, 4, 5, each number multiplied by 2, we'll get 6, 8, 10. If multiplied by 3, we'll get 9, 12, 15. Multiplied by 4, we get 12, 16, 20. The same applies for the rest of the Pythagoras triplets. Like 5, 12, 13, multiplied by 2, we'll get 10, 24, 26. If multiplied by 3, we get 15, 36, 39. Multiplied by 4, we get 20, 48, 52. Similar for the another 2 Pythagoras triplets, and these combinations we'll get. We can use converse of Pythagoras theorem to prove if a triangle is a right angle triangle. So let's see example 7. Determine whether each of the following triangles is a right angle triangle. A. Triangle ABC with A equals 48 centimeters, B equals 55 centimeters, and C equals 73 centimeters. For B, triangle PQR with P equals 30 centimeters, Q equals 20 centimeters, and R equals 21 centimeters. So here is the solution. For A, so the best way we can do is we draw the triangle out. And as you can see from here, the first thing we have to do is we want to look for the longest length, 73 centimeters. So this length C is potential to be the hypotenuse. Okay, this is the first thing that you need to do, find the longest side. Then we want to label the diagram. So the capital letter A, B, C will be the vertices of the triangles. And the opposite sides of each vertex will be the small letter. Let's say this is capital letter A. The opposite side BC will be the small letter A. So which means this length BC is the A here, which is 48 centimeters. Similarly, this is vertex capital B. So the opposite sides AC will be the small letter B, and the value is 55 centimeters. Okay, so same case for the C here. So this vertex is capital letter C. The opposite length AB will be the small letter C here, which is 73 cm, and it is also the longest side. So this will be potential to be the hypotenuse. So I will calculate the C square first, which is 73 square. The value is 5,329. Then I will calculate separately the A square plus B square. So for this case is 48 square plus 55 square, which is 5,329. Then I compare these two values. Are they the same? So for this case, yes, both are the same. Hence, I can make a conclusion that C square equals A square plus B square. So from here, we can tell that triangle ABC is a right angle triangle. Okay, so we do the similar thing. So this will be 90 degrees here. We'll do the similar thing for B here, right? Triangle PQR. So first we sketch out the diagram. All the vertices are labeled with capital letters P, Q, and R. And the longest side will be the P here, small letter P, which is 30 centimeters. So this length will be 30 centimeters. So this will be vertex P, capital letter P. So now this is capital letter R. The opposite side is QP, will be the small letter r, which is 21 centimeters. So same case for vertex Q, capital Q here, opposite side, which is RP, will be the small letter q, which is 20 centimeters. So this length will be 20 centimeters. After that, we can calculate the c square and a square plus b square separately. So for this case, the hypotenuse is 30. So p square equals 30 square, which is 900. Then for b square plus c square, for this case is q square plus r square. The value is 20 square plus 21 square, which is 841. And now I compare these two values. I find that p square is not equals to q square plus r square. Hence, I can make a conclusion that triangle PQR is not a right-angled triangle. You can try this example yourself. Determine whether each of the following triangles is a right-angled triangle. A. Triangle GHK, where G equals 4.5 centimeters, H equals 2.8 centimeters, and K equals 5.2 centimeters. B. Triangle XYZ, with X equals 33 centimeters, Y equals 65 centimeters, and Z equals 56 centimeters. You can pause the video and try to do it yourself. Remember to sketch the diagram first before you want to prove. Alright, so here's the solution for A. When you sketch the diagram, so this will be how it look like. And the hypotenuse is 5.2. The potential hypotenuse will be the 5.2 centimeters, which is the longer side. So I've calculated separately. K square equals 5.2 square, which is 27.04. G square plus H square is 4.5 square plus 2.8 square, and the value is 28.009. From here, we can see that the c square is not equals to a square plus b square. Hence, the triangle GHK is not a right-angled triangle. Let's move on to B. Again, we have to start with drawing the triangle. So this is the triangle, and the potential hypotenuse will be xz, which is the longer side, or the y. So y square equals 65 square, and the value is 5,225. Then we find the a square plus b square. So for this case is x square plus z square. The value is 33 square plus 56 square, which is 4,225 as well. So from here, we can make a conclusion that the y square equals to x square plus z square. So hence, the triangle XYZ is a right-angled triangle. Now, let's end the lesson with this last example, example 8. In the diagram, so here's the diagram. D is a point on the side AB of triangle ABC. Given that AD equals 20 centimeters, BD equals 25 centimeters, BC equals 28 centimeters, and AC equals 53 centimeters. Find A. The length of CD, and B. The shortest distance from B to AC. So here's the solution. As we can see from this diagram, we will look at to find the length of CD. We might immediately think that this triangle BCD is a right-angled triangle, but you have to be careful. It is not mentioned in the question, and it is not labeled as 90 degrees here. So what you have to do is you have to prove that this triangle is a right angle triangle first. So to prove the triangle ABC is a right angle triangle, so the AC is the longer side, which is potential to be the hypotenuse. So in this triangle ABC, we will find the value of AC square first, which is 53 square, and the value is 22,809. Next, the other two sides, which is AB and BC. So we will find AB square plus BC square. So AB will be 20 plus 25, that is squared. BC will be 28, then square. So the answer is 2,809. Now we compare these two values. The square of the hypotenuse is the same as this AB square plus BC square. Right? So from here, we can say that this angle ABC is 90 degrees. Okay? So once we already confirmed that this is 90 degrees, then we'll look at the triangle BCD. Okay, and the CD will be the hypotenuse. So to apply the Pythagoras theorem, CD square equals the BC square plus BD square. Then apply the values here, 28 square plus 25 square. CD will be square root of 1,409, which is 36.5 centimeters rounded up to 3SF. Okay, now for B, to find the shortest distance from a point to a line is the perpendicular distance from the point to the line. Okay, so hence, let's label this length, right? It is perpendicular to AC. I will label this point as point E. So from here, BE, this length, will be the shortest distance from B to AC. Okay, so from here, by considering the area of triangle ABC, the whole thing, right? So we can, since we are referring to the same triangle, we can choose different sides as the base. So first, I can choose AC as the base. Hence, I have this equation. We know that the area of triangle is half times base times height. So it's half the base is AC, and the height is B. Or we can take AB as the base. So BC with the height, hence it will be half times AB times BC. As I mentioned just now, right, since these two are the same triangle, which is triangle ABC, so the area will be the same. So from here, we can cancel the half, then substitute AC to be 53, which is given, then times the BE, which is the unknown. AB will be these two, right, 20 plus 25, which is 45, and then the length of BC is 28. So I have this equation, 53 times B equals 45 times 28. Hence BE will be 45 times 28 divided by 53. Calculate the value. It is 23.8 centimeters rounded off to 3SF. So this will be the length, which is also the shortest distance from B to AC. The value is 23.8 centimeters.